problems. I can spend more as we go through it. All right, the first thing we have here in this one that I want to do is number 3. Number 3 says, as it says, the log base 9 of AB over the square root of 2. Okay, how many different terms I have there? A little bit louder. How many different terms do I have in this? 3. And so there's 3 things that you've got to account for. And again, this says log base 9, so all of the answers are going to be log base 9. So log base 9 of A plus log base 9 of B, because that multiplication right there, and to get something in the denominator, I expand it to log base 9 of the square root of 2. Now yesterday I tried to get you to see this by taking something like, I don't know, I took the log of 100. You remember what the log of 100 was? 2. So the log of 100 is 2. And so I changed the log of 100 to the log of 10 squared. Because why? What's 10 squared? 100. So you can change that. You can change that to 2 times the log of 10. Well, what is the log of 10? So what's 2 times 1? Yeah, it's the same thing. It works. Guys, that's the same thing. So that means the log base 10 squared is the same thing as 2 times the log of 10. That's a rule. So when this says the square root of 2, you just have to know that square root of 2 is the same thing as 2 to the 1/2 power. And again, what you can do with the 1/2 is you can bring it down in front. Some of you are afraid that you're not going to know what to do here if it says something that you don't necessarily, guys, it's not going to, don't necessarily understand, it's not going to say log base 9, log base 8, log base 7. They're all going to have the same base. They're all going to have the same base right there. So in number 3, when you expand it out, guys, that's expansion. Going one way is expansion. Going the other way is condensing. Guys, when you condense, you have 1, 2, 3. Guys, I have 3 things that have natural log by number 6. So I'm going to go down to 1 natural log comment. And every time I have a positive, x minus 4 squared, I'm going to put it on top. 3 times natural log of y is y cubed. On top. On bottom, guys, on bottom here, I have a 6 and y. Well, if I take this now and I simplify, as I simplify this stuff, y cancels out here. 1y on bottom with 3 y's on top leaves me with y squared on top. So then my answer should look like this. Natural log of y squared times x minus 4 squared over 6. Now, guys, what they'll do is, in a final answer, they'll make it look a little bit more difficult than that, because this is a good time that we could review, guys, we could review squaring x minus 4 squared. What is the method we use to square a binomial? FOIL. So that's x minus 4 squared, which gives us x squared minus 8x plus 16. As again, x minus 4 times x minus 4. Then really and truly I have a y squared to distribute. So I might want to distribute that, and then all of it's over 6. So quite honestly, the final answer would probably be the natural log of x squared y squared minus 8x y squared plus 16 y squared, because you got to distribute that, all of that over 6. And then you just took it, you went from 3 natural logs to 1 natural log to figure out that answer right there. Again, make sure you work the other ones, guys. This particular one here is a little bit harder than the other ones, but work them all. Check the video, but check back with the video and make sure you've got them. So in number 9, number 9 is using your calculator. Again, it's just using your calculator. Log base 6 of 5/3. And so many of us don't know what the log base 6 of 5, as nobody does. Not so many, nobody knows that. I've been trying to get you to mess with these to do ones that you know what they'll be because they're a nice even number. Guys, but this isn't a nice, neat, even number. There's no way that you can do this other than use some kind of technology, a slide rule, a calculator, what. So 5/3 over 6. So seriously, guys, in this chapter, what I'm teaching you is what buttons to push to get the right answer. Again, you have to close that 5/3 divided by log of 6. You have to close those parentheses. As in, that's the answer right there. That's it. 2.9, no, 0.29. As nobody's got this memorized. It's not something that you just look at and know. That's what I meant by this stuff is not intuitive at the beginning, 6 weeks ago. As you're not going to look at the log base 6 of 36 and just magically figure out that that's 2 because you understand math better than a person. Guys, it doesn't work that way. You gotta mess with this stuff a little bit. So 6 to the x equals 36. When it's one like this, and you can get it to the same, that x equals 2. Oh, okay, that's doable. You guys, other than those ones that work out evenly, you have to use your calculator. That doesn't make you bad at math because you're using a calculator. That doesn't mean you don't know what you're doing because you have to use a calculator. As it's what you do to solve these problems. It's what you do to solve these problems in number 14 when you say 4 to the 2x equals 16. And again, in just a second, I'm going to divide by 2 to get rid of a 2, or I'm going to add 1 to get rid of a 1. That's what you do. If it's a plus 1, you subtract 1 from both sides. It goes away. If it's a times 2, you divide by 2. It goes away. In this problem, guys, you can say 4 to the 2x equals 4 squared. The reason that you would want to do that is because these are the same bases. Guys, and once you get to the something to the same base, drop the base, solve the problem. 2x equals 2, x is 1. What's the next one? 15? It's no different. In number 15, I have 2 to the 2 squared to the x over 3 equals 2 to the third. Again, I got them to the same base. So 2x over 3 equals 3. 2x equals 9. X is 9 over 2. That's what one person did. Somebody else solved this problem and they looked at it and said, well, Coach Hill, I would rather get rid of that 4. So they had 4 to the x over 3 equals 8 and knew that they wanted to get rid of that 4 right there. So again, guys, in some problems, you subtract 7 from both sides. Why would you subtract 7 from both sides in a problem? Give me somebody, what would it say? It would say what to cause you to subtract 7 from both sides? Is it a plus 7, right? So what would you do? You'd subtract 7 from both sides. Why? To get rid of it. To get it with 1 by itself. Because that's 7 minus 7 is 0. So then the next step it said, I don't know, negative 3x equals whatever. And what would you do? You'd divide by negative 3. Yes? Yeah. Why? Get x by itself. To get rid of it. Guys, in this stuff, you do the same thing. We just have guys, it took us years and years and years and years to get comfortable with adding 3 to both sides, dividing by 5 from both. You may get rid of that by finding the log base 4 of both sides. Because we talked about this the other day. A log base 4 of 8. The other day we said this right here is 1. Anytime you have the log base of the same number right there, that's always 1. So that would bring the x over 3 times 1 would give me x over 3 equals, guys, use your calculator. Log of 8 divided by log of 4 is what? 1.5. That's what it is. Guys. 3 times 1.5 is 4.5. Which way is right? Guys, that's going to happen more often now. I know you think the harder a problem gets, the more black and white the answer is. Guys, the harder a problem gets, the more ways there are to solve it. Look around the room. Nobody in the room is dressed alike. It's a problem. You got to have clothes on. Got to have clothes on. But look, there's a bunch of ways to solve it. It doesn't bother us in our personal life. It shouldn't bother us in our mathematical life. Okay, it's the same concept. Look, as long as I keep everything covered up, I'm good to go. All right? That's what it is that you're doing here. Flip over on the back, up to number 18, guys. I would warn you tonight, you better look at number 17. Somebody asked me to work this one here earlier, and I said I would. But guys, you better look at number 17, because 17's much different. Can anybody tell me why 17 is much different? Less than or equal to. Less than or equal to, guys. Those ones that are less than or equal to, remember that's x is greater than 0. So this is natural log of x is greater than 5. Again, for those of you that try to figure out a way to say, you convince yourself, you can convince everybody that you don't know how to do, because it's so confusing. Guys, everybody in the room understands why I divided both sides by 2. To get rid of it. You do the same thing, it's just that we're not comfortable yet with taking that and saying that eliminates itself, but if I do it to this side, I have to do it to that side. So x is greater than e to the 5th. Let's think about this for a second. This is 2 times natural log of, let's say if this was e to the 5th. Well, based on what we talked about, that right there is 5. 2 times 5 is 10. So as long as I pick a number that's greater than e to the 5th, it'll work. Now, that's not going to be my final answer, though. The reason that's not going to be my final answer is because you got to figure out what e to the 5th is. And again, I'm back to that concept of us understanding that, guys, you have to use some form of technology to figure out what e to the 5th is. And that's 1.48.41. So 148.41. So x is greater than 1.4841. The only thing is that's not how it's going to be written. It's going to be written like this, 148.41, comma, infinity. It's going to be a bracket, or excuse me, a parenthesis, because that's that. Again, I keep showing you this. The other day, I've been showing this every day since how long, and somebody in my 6th period class went, I didn't even know you had a website, Coach Hill. I change this stuff up all the time. There's videos there that you can watch. This, guys, this right here is there for you. Here's some great stuff that we're going to week to practice this. Here's all the different sections that we've done that I'm going to let you work on to show you that you can do some of this stuff. Okay? And this is good stuff, but it's just there. It doesn't become a review. It doesn't become work until you do something. Okay? Where are we at? 21? Again, guys, don't forget to check the problems. Over here, I'll put these formulas up here today. Tomorrow, they'll be up here. You got to be able to pick out the one to use. So make sure you pick out the one you use. Okay. 7 says same scenario as number 20 for an interval of what time? So it says you buy a car, you buy P equals, or A equals P times 1 plus or minus R to the T. How do you know whether it's exponential growth or decay? Depreciates. Depreciates means what? Plus or minus? Minus. So $14,000, guys, is 1 minus 0.1 to the T. And I have no earthly idea why this is such a big deal to us, but guys, I do know that it is less than when is this less than $8,000? So less than 8,000. I do know that it is a big deal when they ask you to make this into a model, guys. If they say model that, all it means is plug it into your calculator, guys. 14,000 times 0.9 to the x. 1 minus 0.1 is 0.9. Guys, that's a picture of it. Oh, that's a picture of it right there. Can't see it because my window's not set. I'm meaning to hit table. But there's a picture of you buying that right there. Now, it wants us to calculate it out. It wants us to figure out what divide by 14,000. That's divide by 14,000. Again, this is 0.9t is less than whatever 8 over 14. Let's see, 8 over 14 is a fraction. 2 goes in there 4/7. So this is 4/7. Nice. Again, there's no other way. There's no other way where this says 0.9 to the t, not 0.9t. Again, if it said 0.9t, I would divide both sides by 0.9 and be done with it. Okay, you guys that just said that, you understand the logic behind doing this. What you're just not comfortable with yet is whatever that base is, take the log of that, and it's 1. But if I do it to this side, I got to do it to this side. So t is less than whatever that is. Guys, again, the person who looks at that and goes, oh, they don't exist, guys. It doesn't make you bad at math because you have to use some kind of technology to figure that out. As you log of 4/7. As log of 4/7. You hit log 4/7. What I'm teaching you is close that parenthesis right there. This is what I'm teaching you that's new. Log of 4/7 divided by log of 0.9. You can't put 9, you got to put 0.9. Again, you got to close that parenthesis. And it gives you 5.3 years. So somewhere between year 5 and year 6, according to the model, this thing should get down. Look, here's 5, 8,000. Here's 6, 7,000. So somewhere in between these 2 years, more specifically, exactly when it is, it's 5.31 years. So less than 5.31. I guess it wants to know when it's less than, when which one exceeds. Let's see, make sure I read it right. For what period of time did the value of the car exceed 10,000? For what interval or time is your, so this is when it's, so it would be this. It wants to know when this, so as long as the time is greater than 5.3 years, the amount goes down less than $8,000. All right, let me go ahead and hold off on number 22 and 23. I'll do 22 and 23 as a warm-up tomorrow.